Hi, today we are working on problem 22.32 on mastering physics. Um, there will be part A, given a chart at the origin. So you want to draw a really nice picture of a chart at the origin. A positive 12 nanocoulomb would equal to 12 times 10 to the 9 coulomb, negative 9. And put a point at 5 centimeter away. 1, 2, 3, 4, 5. So 5 centimeter and 0 centimeter right here. So 5 centimeter convert would equal to 0.05 meters. Okay, for a positive charge, it will have an electric field that is pointing away from its origin, from the source, like so. So to look at these pictures, you can say at point 5 centimeter away from the origin, the electric field is to the right of the x-axis. And to the y, since there's no component vectors, this y is 0. So you can say e to the y equal to 0, because the distance is 0. And you can find e to the x would be equal to positive k, the chart at the source, which is qa over r, the distance square. I would call this b just to make it easier. So rab square would equal to 8.99 times 10 to the 9, the absolute value of 12 times 10 to the negative 9. Since 9 times 10 to the 9 and 10 to the negative 9 can cancel, you're left with a nice number over distance is 0.05 square. So after computing, you would given this number 4.3 times 10 to the 4th nanocoulomb, or 43152 nanocoulomb. But this one is nicer and shorter. For part B, they given you the distance of a plot at negative 5 centimeter and 5 centimeter, and the origin is at the same place. So draw a nice picture. 1, 2, 3, 4, 5.
But it's not why you want it. Oh yeah, it's not like
1, 2, 3, 4, 5. The plot is there, and the chart, the same place, same kind of chart. Positive 12 nanocoulomb, 5 centimeter away, so 0.05 meters, 0.05 meters. You can nicely do this dotted lines here. Will help you to indicate the angle later. So to find, I would like, so then there's in this plot right there, you would have a component vector x and y, like that. However, since a positive charge will give you a force field, electric field, not force field, electric field like this, away from origin, you can say the direction and the y direction is positive because it's pointing upward, and the direction for the x direction is negative because it's pointing that way. So you can write it. Equation for electric fields in the x direction would equal to negative k q a over r a b square. However, this is not equal to the earlier example. This including a angle, so you can choose whichever angle you want to choose and stick with it as long as you're consistent. And to find the angle, a perfect square, when you divide it by half, it would be 45-degree angle. Or you can use tangent theta. Tangent theta equal to 0.05 divided by 0.05. So therefore theta equal to inverse tangent 1. Then it will give you a 45-degree angle. So since I choose my angle over here in the x direction, which is this one, you would use with this angle you would use cosine, because cosine is adjacent, not adjacent, yeah, adjacent over hypotenuse. Or you can just cosine theta, and then you put the number negative 8.99 times 10 to the 9 multiply with absolute value of 12 times 10 to the negative 9 multiply with cosine of 45 degree and divide it by the distance. Here you can find it with the Pythagorean. Call this A again. A, B, call this B, and then I call this here over here C. AB square equal to AC square plus CB square. So therefore AB equals to square root of 0.05 square plus 0.05 square equal to 5 times 10 to the negative 3 is under the square root. So you plug this back into our square. B 5 times 10 to negative 3 square. This will give you this number, negative 15256 Newton Coulomb, or negative 1.5 times 10 to the 4th nano Coulomb. Next, to find E in the y direction, you do the same thing. K Q A over R A B square. Since you already find the direction of the y is positive, so you can put a positive right there. Multiply with sine theta, because pictures here, this pictures to find theta and to find this y, so it would be a sine over that, would be a sine theta, and you plug the number in. 8 times 8.99 times 10 to the 9 multiply with 12 times 10 to the negative 9 sine of 45 degree divided by 5 times 10 to the negative 3 under the square root, square, since these two squares, so it's cancel, would equal to Also 1.5 times 10 to the 4th nanocoulomb. So you would put it like so, negative 1.5 times 10 to the 4th in the x direction, and 1.5 times 10 to the 4th in the y direction. The end.